Hello, everyone, and welcome to the P21055 umbilical cord clamp redesign lightning talk. So before we get into the nitty gritty of our project, we're just going to take a minute to introduce the team. I'm Kevin Arnold. I'm an industrial and systems engineer, and I'm working as the project manager.
Hi, everybody. My name is Kiara Santina Young. I'm a biomedical engineering student, and my role is with client relations.
Hello, I'm Charles O'Cahey. I'm a biomedical engineer, and my role is the team facilitator.
Hi, I'm Alex Mickett. I'm also a biomedical engineer, and I'm serving as one of the systems engineers.
Hi, I'm Noah Huguenine. I'm a mechanical engineering student, and I'm also a systems engineer.
Hi, I'm Sierra Shemaine. I'm also a biomedical engineering student, and I'm our purchasing coordinator. So as Kevin mentioned earlier, we were tasked with redesigning an umbilical cord clamp. And the purpose of these clamps is to stop blood flow along the umbilical cord between mother and baby and to promote healthy healing of the navel. But current gaps in the design are that the umbilical clamp is difficult to handle in the birthing environment due to gloves and other fluids, and it can tend to slip off on larger umbilical cords.
This project was brought to us by Divergent Medical Technologies. This company specializes in newborn security through mother-baby matching. They have an identification number on the side of the umbilical clamp that gets associated with a same number on a mother for this matching and tracking of the baby in the hospital. The Umbilical clamp is also part of Divergent's newborn identification kit, which features include the identification number, as I mentioned, as well as electronic tracking of the baby. Divergent contacted our team and asked us to improve their umbilical cord clamp design, addressing some of the gaps that Sierra just mentioned, while also maintaining their security functions.
So Divergent's main competition is the Hollister clamp. It is currently the industry standard, so that's why we included it in our benchmark testing. The main difference between Hollister and Divergent is that Hollister does not include tamper-resistant clasping, which is Divergent's claim to fame. So Divergent goes the extra mile to ensure newborn safety and security.
The overall goal of our project was to improve the user experience and decrease the potential for failure by addressing the ergonomic issues of the previous design, as well as allowing for increased flexibility to accommodate larger umbilical cords. Pictured here are two of our previous iterations before we settled on a final model for our design.
So here we have outlined a roadmap of the project. We had initial intake in August at the beginning of last semester, where we presented with the project readiness package and the things that the customer wanted to improve upon. And after that, we started collecting voice of customer to generate customer and engineering requirements, which led us to brainstorming on an initial design and then 3D printing and prototyping it. And this was an iterative process that included prototyping and then testing it against a benchmark and then gathering even more customer feedback. And through these iterations, we plan on making a final decision and handing it off to the customer at the end of the semester in May.
Throughout this project, we faced three main challenges: prototyping through 3D printing, human subject testing, and then lastly, the COVID-19 pandemic. So with our first challenge, we were limited to 3D printing, and injection molding, the preferred method for our final product, was too expensive for our budget. However, we were able to utilize on-campus resources to quickly print out prototypes through 3D printing. Although convenient, these printers were not very precise considering the size of our design, and the available materials didn't meet our ideal mechanical properties for our final product.
Another challenge the team faced was to set up human subject testing because it is difficult to find donated umbilical tissue, as well as there were limited opportunities for clinical lab uses outside of research for COVID-19. However, by doing this human subject testing, we are able to accurately represent what a birthing situation would be like when using our redesigned clamp, as well as to build relationships with medical professionals.
One more challenge that the team faced was the COVID-19 pandemic. This led to decreased in-person collaboration as well as decreased availability of materials and resources. However, it did allow us to meet virtually and get experience working in an alternative environment, so that was a valuable experience that we gained.
So to wrap up our journey with this project, we were able to take it all the way from a list of customer requirements and brainstorming, all through various stages of design work, all the way to creating a functional prototype. Once our term here concludes, we will hand off our final design where our customer will create a injection mold for that and mass produce it and hopefully get it to market as soon as possible.
Thank you, everybody, for listening. We'd like to say a special thanks to a few people who have helped us along the way. Art North is our team guide for the Multidisciplinary Senior Design Program. He has helped us to grow as engineers and to maintain a relationship with our clients. Dean and Joyce Trevisani, as well as John Mitchell, are our clients from Divergent Medical Technologies. They've been very involved and have provided a lot of constructive feedback that have brought us to where we are with our project today.
We would also like to thank our medical professional, Olivia Croston, as well as the rest of the RIT faculty and staff for all their experience support throughout our project.